Hello everyone, welcome to this video. In this video, we are going to learn about conformal prediction using OpenMathAI. So, let's get started. What is conformal prediction? Conformal prediction is not a machine learning algorithm, but a model-agnostic framework that works with any regression or classification model to provide prediction intervals instead of only a single predicted value. Unlike linear regression, which predicts only one value, conformal prediction estimates a range of values where the true result is likely to lie with a chosen confidence level, such as 90% or 95%. Conformal prediction first trains a machine learning model, then uses a calibration dataset to measure the model's past prediction errors. When a new prediction is made, it adds and subtracts an appropriate error from the predicted value to generate a confidence interval, helping users understand the uncertainty of the prediction. For example, suppose a linear regression model predicts that a 1,700 square feet house costs $47.5, instead of returning only $47.5. Conformal prediction may provide a prediction interval of 43.5 to 51.5, 95% confidence, indicating that the actual house price is likely to fall within this range. As a result, conformal prediction improves the reliability and trustworthiness of machine learning predictions by quantifying uncertainty, making it widely used in healthcare, finance, weather forecasting, and autonomous systems. We will use this dataset for the conformal prediction model, so let's get started. Open OpenMathAI. In this demonstration, we use the house price prediction using conformal prediction model. Click Create New Project. Enter the project name as House Price. Choose a folder location to save the project, then click Save. To import your dataset, either click Load Example Dataset or browse for dataset to import your own CSV file. Once the dataset is loaded, verify that it contains all columns before proceeding to model training. Scroll down to view the first 10 rows of sample data. Click Continue to Configuration to proceed. Configure the dataset by specifying the input features and output target. There's also a feature called Ignore, which can be used for columns that should not participate in model training. Select the input and output columns manually, or use Smart Suggest for automatic recommendations. There's one more feature, Signal Diagnostics. There's 3 columns. First one is column. It's tell which features are in the dataset like inputs and outputs name. Second one is VIF. It tells how much correlation of the features. Third column is status, if it's okay, moderate, high, redundant, and constant. Review the selected configuration. Click Proceed to Model Design. Choose a model from the available machine learning models. OpenMathAI recommends suitable models and features based on the dataset. For this demonstration, select the conformal prediction model. View the model overview, pros, cons, and real-world applications. Click Proceed to Training. You will see the selected model. Click Start Train Models. Review the training configuration. Test data split, which determines the percentage of data reserved for testing and validation. Review the model parameters and pre-processing settings. And also another feature is added that is train from scratch or continue from use model. If you train this model before you use that option. Modify the configuration if required. Click Start Training to begin the training process. After training is complete, review the following performance metrics. R-squared measures how well the model explains the variation in the output data. Range 0 to 1. MSE, mean squared error, measures the average squared difference between actual and predicted values. RMSE, root mean squared error, the square root of MSE. RMSE is expressed in the same units as the output variable, making it easier to interpret. Engine time, the time required for the generated model engine to execute and produce predictions. Lower engine time indicates faster model execution, which is important for embedded systems and real-time applications. Fit quality, an overall assessment of how well the model fits the dataset. It is generally derived from metrics such as R-squared, RMSE, and residual errors. Model accuracy. For regression models, accuracy is commonly estimated using the R-squared value. Example, R squared equals 0.95, accuracy almost equal to 95%. Click Fit to Window, you will see 3 types. Fit to Window, comfortable, compact. Then the clear history. If you click, that it will clear the history before its trained model. Another is deselect and select all trained models for export. Click View Curves. You will see the diagram of R squared residuals and residuals diagram. Click Math and Code Preview. View the generated mathematical equation and source code. OpenMathAI provides expression of the data, detailed explanation of the expression, and an implementation code. Return to the results page and click Deploy Status. Click Export Model. Choose the required export format. ANSYS, FMU 2.0, FMU 3.0, Verilog RTL, VHDL RTL, Python Bundle, ONNX-Hub. You can choose any of these format and export. You can also download the free trial versions of OpenMathAI and Twin Simulate. Thank you. Stay tuned for more OpenMathAI demonstration.